Dear students, good morning. Now we'll proceed to Unit 4. So, Unit 4 is 3G and beyond. So, basics of 3G has been introduced already. So, introduction is over. And then MTT 2000. So in 3G only, as I said, we had WCDMA, CDMA 2000, Edge, Wi-Fi, WiMAX, OFDM, MIMO. So the important parameters are Edge, Wi-Fi, then WiMAX, then OFDM. And also MIMO. So these are the things which we have to study in Unit 4. So as I said, wireless system evolution, cellular networks started from 1G, 2G, 2.5G, 3G. So coming to 3G, we are going to study about GPRS, that is General Packet Radio Service. Next one is Edge, which is enhanced data rate for GSM evolution, and then universal UMTS, which is nothing but universal mobile telecommunication system, and then 3GPP, that is third generation partnership project. So these are the things which is extra, which we are going to study in 3G networks. Okay. So coming to evolution, if you are talking about evolution of 3G, then we have to say that it is having GSM, GPRS, Edge, which is converged to 3G. Similarly, CDMA 1, CDMA 2000, it will be leading to 3G. Similarly, TDMA, Edge, it will come to 3G. So, whatever may be the technology, in all way, it will be leading to 3G. So, that is why 3G is best for the attracting the subscribers. Now, if you are to compare 2G and 3G, you can say this both are digital technology, but in 2G what happens, we have modulation, speed, channel coding, data control and data channel, but here it is used increased use of digital technologies. Radio, software defined radio is used. Software defined radio is an important keyword which is introduced in 3G, in which makes revolutionary in digital technology. Next one is frequency bands. So operate in multi-frequency bands, that is 800 megahertz, 900, 1.5 gigahertz and 1.8 gigahertz. But here it uses a common global frequency band for both terrestrial and satellite components. Example, the band will be 450 to 470 megahertz, or 698 to 790, and similarly 2300 to 2400 megahertz, 2500 to 2690 megahertz, 3400 to 3600 megahertz. So likewise many bands can be used and commonly used for different operating environments. Suppose if it is 2G, primarily optimized for specific operating environments such as vehicular and pedestrian environments only. But here maximizing commonality and optimization of radio interfaces, multiple operating environments, that is vehicular, pedestrian, office, fixed, whereas access and satellite operations. Coming to roaming, limited to specific region, and it is a global roaming due to the global frequency coordination. And then technology, spectrum efficiency, overall cost and reliability, and limited by the system design operative. Coming to 3G, those costs are improved as a result of building upon second generation wireless system design experience. Okay. So this is evolution and comparison. And if you want to compare this UMTS, what is there which we can call here as UMTS, that is important because this UMTS is a sector which is used for UMTS is universal terrestrial mobile, and hence this will be used here for various purposes, and hence this can be IMT is International Mobile Telecommunication System, which is used for this a standard which is proposed for this communication system. Okay. Likewise, it is also used for the edge enhanced data rate for GSM evolution, VHE, and then fixed to GSM global, and all these are practiced with the help of the mobile systems. Okay, so here the data rate for global multimedia mobility is 144 kilobits per second, and minimum is up to 2 megabits in urban area it can go. Okay, so that is the standard for this one. And when we are going to talk about this frequencies of IMT, there are you can refer our Rappaport books where the frequency is given in detail. Then IMT for 2000 family, as I said, it is for GSM and IP network. So this is also an important terminology which we have to use it. And next one is UMTS architecture. This was released during 99, and then this is used as the main thing which we can use here is cell level mobility, radio network subsystem, encapsulation of all radio specific tasks, and then USC user equipment, CN core equipment, and the inter-system handover, location management if at all it has been devised, and then we can see how it has been used with the user equipment and core equipment. So UTRA network will be acting as a mediator between the user equipment and CN equipment. So likewise, this can be also used as a domain for interface, and then we can also consider the power, so that this can be used for the various purposes. And user equipment infrastructure domain shared among all the users who offers the overall OMTS services to all the accepted users. So that is another important one. And this universal subscriber identifier model, that functionality for encryption and authentication of users located at SIM inserted in a mobile device, and mobile equipment data, functions for radio transmission, and user interface for establishment, maintaining, and end-to-end connections. Access network domain depends upon the functions. Core network domain, access network independent of functions, and serving network domain, network currently responsible for communication, home network domain, and location and access network independent for all functions. So the next one is spreading and scrambling of user data, where it is containing chip for the multiple purposes, and then we can also use this for user separation via unique different thing. And now the users are not separated via orthogonal spreading codes. So much simpler management of codes feed station can be used for same orthogonal spreading codes. So precise synchronization not necessary, as a scrambling codes stay quasi-orthogonal. So that is the advantage of this technique. And then if you are seeing the frame structure, it will be different to that of UTRN network. And coming to the protocols which is being used in the core network, the core network thus interface with core circuit switching domain, packet switching domain, and release 99 uses the GSM GPRS network and add a new radio channel which is most important access. Okay, so that is more important in protocol. So support of mobility, macro diversity and minimum diversity is required, and this part is used for multicasting of data via several physical channels, enable software handover FDD mode only. So uplink means simultaneous receptions of UE data at several node Bs, a reconstruction of data at node, and in downlink the simultaneous transmission of data via different cells, different spreading codes in different cells are used. So you students, I think you have understood the support of mobility